I didn't realize how nasally I sounded, but that's just tough. I just listened to the other part. You'll just have to enjoy it while I'm sitting in my long meeting and you're taking notes. All right, so let's start here on B. We're going to talk about a new word to us, and it's a condition of equilibrium. Now, there's no way I can spell that right or in that amount of space, but it says equilibrium will be reached. All right, that is referring to up here. Whenever we put our sugar in our milk, we put the sugar in until it can't dissolve anymore, and we have what we call an equilibrium. What that means, if I look down at my picture again, it means I have some sugar that's breaking into its parts, but also some sugar that's falling back into the solid on the bottom. Now, if one goes out and one goes in, the change is actually equal to 0. All right? That's what an equilibrium is. There are things changing, but the net change is 0. It's kind of like my bank account. The first day of the month, I deposit almost $3,000. I know, I'm loaded. All right? But then I pay my house payment, my insurance, all the other stuff, I don't know, and it seems like I spend $3,000 every month. So even though I had plus 3,000, I have a minus 3,000. So it's 0. I have different money in there, but the change is 0. There is no net change. All right, that's what an equilibrium is. All right, and it's going to say that. There is no net change in the overall system. If you took 2 steps back and 2 steps forward, you had gone somewhere, but your overall change is nothing. All right, so here we go. Number 2, particles of solute. Now remember, solute in our example, let's write it up here. Solute is sugar. Our solvent equals milk. All right. All right, so back here to number 2. Particles of solute or sugar move from the dissolved to the solid state. Uh-oh, I messed that up. You already wrote it down. I can erase it. If you wrote it in pencil, fix that. I should have read it first. All right, sorry. They move from the solid to the dissolved state and back to the solid state. All right, this solid to dissolved process happens at the same rate, producing a dynamic equilibrium. The same rate means that if 2 dissolve, then 2 come out. If 3 dissolve, then 3 come out. There is no change in the overall system. I don't know how many times that I've had to say that already, but trust me, in equilibrium there is no change to the overall system. Say it out loud. Yes, I mean it. I didn't hear you. There is no change, net change in the equilibrium. All right, I don't know how that went. I'm not there. Okay, so make sure you understand what an equilibrium is. All right, it's where our sugar, back here, it moves from solid sugar to dissolved sugar and then back out. That's because it's saturated. If it wasn't saturated, the sugar would go in and split apart and stay apart. All right, now let's do this real quick. Definitions. A saturated solution holds the maximum amount of solute for a given amount of solvent at a constant temperature. All right. That is on your test. Make sure you understand what saturated is. Just here in the next clip, we'll cover supersaturated and unsaturated.